So, okay, our YouTube stream has just fired up, so you should be able to see the visions side of things on YouTube, my YouTube channel, VK3CSJ. Just look for the live indication, and that should bring up a picture, although I haven't quite got the camera on me yet. And also Discord, and as I've mentioned in the past, Discord is probably a better medium because the delay is less than a second. So whatever I mention here live on 80 meters, as far as visual aspect, you can pick it up on Discord with less than a second, whereas with YouTube it's 20 seconds. You've got to wait for the for things to catch up. So Discord, all you got to do is just to go to the Discord website and register, download the app or the program, and register. No money involved, just registering. And then the link, I provide a link straight to my chat room and the HD stream on the QRZ.com page. So if you go to VK3EKH on QRZ.com, and a few paragraphs down, I make reference to Discord, and there is a link that I provide, which should take you, and it does take you, to the astronomy chat room, not radio astronomy, the astronomy chat room for this session, and consequently the stream. Right, let's just get one of my cameras going, so it's not always looking at the banner there, the ASV banner, and I think that one there will do for the time being, and I've got none of the lights on either. That'll do. Alright, good evening everyone on this 22nd of November 2024. I hope everybody is feeling well and recovering from today's little heat wave. And tomorrow is going to be just a couple of degrees, probably hotter. Well, I think they're saying 37-ish, so it'll be pretty much the same as today. Current temperature is 27 here at Narre Warren South, 27.6 to be precise, on the Davis weather station. All right. Now, we have an email address if you wish to send signal reports, vk3ekh@gmail.com, vk3ekh@gmail.com for any correspondence that way. Otherwise, the chat room is the other option to say hi. And, okay. I'm just a little bit distracted because of the A2 repeater not being working. Where am I going to now? It's really just the usual bit on. Can we get out of that? And on the ASV. So. Just waiting for my computer to wake up. For those that aren't aware, the Astronomical Society of Victoria is a non-profit society for people interested in astronomy. It attracts and caters for people from a wide range of ages and backgrounds, abilities and interests. It was first formed in 1922, and the society has grown to over 1,600 members. I think it's around 1,800 was the last figure I heard, actually. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our two metropolitan locations, the Morley Community Village and the Melbourne Observatory. And we host monthly Astro Talks at the Herbarium near the Melbourne Observatory. The Society's library is also located at the Melbourne Observatory and is open during our Astro Talks. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for people gatherings throughout the year, bringing telescopes and astronomy to Melbourne's parks and schools. Please check the calendar on the ASV website for details about these events, so you can see if you can pop along and have a look at what's going on. The ASV is currently involved in a number of major projects. Some are pretty much complete now. We are involved in the restoration of the Great Melbourne Telescope. Still a few more years for that to come to fruition. And also currently working on the installation of a series of remote controlled telescopes at the Dark Sky site, which I believe are also now online and available for members to use with a certain registration process. The ASV is currently involved, I've already read that, thanks to a generous donation from one of the most long-standing and respected member, the Leon Mao Dark Sky Site, LMDSS, located north of Melbourne, just north of Heathcote, has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope, and a wheelchair accessible telescope, 16-inch telescope, which is all located at the Leon Mao Dark Sky Site, and makes use of the existing telescopes at the Melbourne Observatory during some section meetings. And our members' nights are held once a month at the observatory. An annual yearbook is supplied to members, as well as a bi-monthly newsletter. So that's the what they refer to as the yearbook. It's quite a nice little publication which members can get. And the ASV magazine, which used to be called a newsletter, is this little glossy job for those watching video. So I think there's a new magazine that's just been released as well. Haven't had a look at that one yet. Okay, and that the monthly newsletter is a bi-monthly newsletter, which is called Crux, and which is all members are welcome to contribute to. Also on the Dark Sky site is a fully steerable 8.5 metre radio telescope. It's a Kennedy dish, very similar to the dish that Doug MacArthur used to use up at his property, the 30-footer. And it's fully steerable and can point to any part of the sky and track any celestial object. And it can be accessible to members with involvement with the radio astronomy section. A very pleasant good evening to any RAS members that might be listening. Right. The ASV logo shows the Southern Cross, which I can show you on the yearbook for those watching. I think that's the camera I am on right now. That's the logo, the Southern Cross and the pointers. And it has a Latin motto on it, which stands for "This way to the stars." The ASV is governed by a set of rules which should be read before applying for membership. This document may be downloaded from a link provided on the website, although I don't think that link works. Any person or organisation with an interest in astronomy may apply for membership of the society. Join now. Oh, that's what it says there. So, yes, joining the ASV is easy peasy, and it's all via PayPal, so it can all be done online. Within a week, you should receive a membership pack, as I think they refer to it still, and giving you all what you need to know about access to the various aspects to the ASV. Right. Having said all that, it's the middle of the month almost. Well, it's a little bit over that, so yeah, not much I can really else I can refer to at the moment. But having said that, next weekend is the ASV's Starbecue. I do have a caption card for that, which I can bring up on screen. So, damn nuisance that repeater's not working. Um, so yeah, this is the I'm showing on the screen now is more addressed to the public, general public, because the barbecue is open to the public. So and from what I can see, the website's not saying anything about it being booked out. If they had reached their certain number of tickets, they generally indicate booked out across the screen, but they haven't done that. So I have to assume that tickets are still available. So if you go to the ASV website at www.asv.org.au, you'll see the caption that I've got up on screen right now: Starbecue 2024, Saturday, the 30th of November. So it's next week. Adult tickets are $20, public tickets. And there's quite a variety of things happening from about 2 o'clock in the afternoon. So get there early, and there'll be somebody to greet you just past the gate, and there'll be tours of the site. There's a Lions food truck that'll be made available from about 5 o'clock onwards, I would imagine, maybe even earlier. But that's where you'll be able to get your snacks, something to eat for the dinner side of it. And if hopefully the weather will be good. Hopefully the outlook for next Saturday will be ideal for an all-night viewing, because there'll be telescopes set up everywhere. That's the whole idea of the Starbecue, is to organise a ring of telescopes that members bring in. Don't be too surprised to see probably about 15, maybe even 20 telescopes set up in the observing area. There'll be all sorts of telescopes. So, if you're wanting to query about what kind of telescope to get your kids, here's a chance to find out. Because the astronomers that own those telescopes will be more than happy to explain their instrument. What's the little term that they use? Their rig. Yes, they like to use the word rig for their telescope setup. Anyway, but that's all next Saturday. Hopefully the weather will be fine for the chaps that'll be up there. Yeah, so that's next weekend. And if you if you want to trip up there, it's about a 2-hour drive, 2 hours from here. Here's your chance to find out what we're doing with the site. So like I say, just go to the ASV website to find out more information, and once you have booked a ticket, you'll receive necessary information about how to get there and all that sort of stuff. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. We're not broadcasting through the Melbourne television repeater tonight. For some reason, the repeater's fallen over. So all the video side of tonight is through Discord and through my YouTube, which seems to be holding in okay. I'll just have a quick look at Discord. I can see there's a few people there already. There's at least four-ish, or maybe four people watching on Discord as I speak. So a very pleasant good evening to you chaps. And on the chat room, let's have a quick look at the chat room. Steve, VK3SBX, is there saying hi to everyone. Cassiopeia is there. Nebs, good evening all. Hi Clint, yes. Good evening. So g'day chaps. And I'll just have a quick look at my email just to see if there has been any reports come through. Inbox, there it is. Thus far Andrew has checked in. G'day Andrew, VK3KIS, listening on 80 meters or Q5 signals. Excellent, eh? So that's good. That's what I want to hear. All right, I've got a few articles tonight. Let's see if I can burn the next 45 minutes on a lot of stuff. Oh dear. I think this will follow that. Yes, no, or maybe you know. Okay, I'll start off with that one. All right, courtesy of astronomy.com. There's no Tamitha report tonight. Unfortunately, there's no solar weather report from our space weather woman. So she did a report just about over a week ago. So I guess it's not a whole lot's changed in this last week, solar-wise, solar speaking. I've got a beautiful picture here of Uranus, or Uranus. Just depends on what school you went to. Let me bring that up for the first item for tonight. There we are, and I might be able to bring up an insert. Have I got my picture insert running? Yes, there it is. So I'll bring that up. There's me in the insert there. So what's this saying? A blast of solar radiation just before Voyager 2's arrival in 1986 may have misled researchers for decades. All right, let's see what this is all about. In 1986, Voyager 2 flew by the ice giant Uranus. It was humanity's first close-up view of the outer planet, and it remains the closest any spacecraft has ever come. On this trip, the spacecraft found 10 previously undiscovered moons, two rings, and a truly bizarre magnetic field that has baffled scientists ever since. Most of the other planets have magnetic fields that align roughly with their poles, which point up and down, out of the plane of the solar system. But Uranus is unique in that it spins on its side, like a ball rolling around the sun. Even given its strangeness, its magnetic field doesn't seem to originate at its centre, but somewhere far to the south, possibly as much as a third of the planet away, and it is tilted by 59 degrees. There you go. What's more, Voyager 2 noted a strangely intense magnetosphere during its passing, with strong radiation belts and a bizarre lack of plasma. Researchers have been puzzling over these results for the past 40 years, and now a new study published in November 11 in Nature Astronomy has revisited the Voyager 2 data and discovered that Uranus was actually suffering a blast of solar weather, putting it in a state that researchers estimate represents Uranus only 4% of the time, and reframing what little we know about our distant icy neighbour. Somewhere in that sentence there, I lost it. Let's see. I'll just read that again. Now, a new study published November 11 in Nature Astronomy has revisited Voyager 2 data and discovered that Uranus was actually suffering a blast of solar weather, putting it in a state that researchers estimate represents Uranus only 4% of the time, and reframing what little we know about our distant icy neighbour. See, it's the phrasing and where the commas and the full stops are that makes it more sensible. Sometimes I just skip over those commas. Okay, what's next? So putting it in perspective, somebody by the name of Jamie Jasinski, from NASA's Jet Propulsion Laboratory in California, is the lead author of the new study. In the paper, he and co-authors point out that previous studies used Voyager 2's measurements of the solar wind as it was crossing Uranus's bow shock, the outer edge of its magnetosphere, to frame the rest of the observations. But looking at the spacecraft's measurements, it's clear that the planet and spacecraft were swamped by a blast of solar wind at just that time. By looking at the big picture, some 8 months of data, it was clear to them that this is not the norm for Uranus, and explains why its magnetosphere seems so odd. The planet is and remains tilted, which causes some strangeness in the magnetosphere. But the inexplicable part of that for researchers has been the lack of observed plasma. Uranus's moons, we now know of 28, including 5 large ones, were expected to behave like other outer solar system moons, icy and likely to spew ions, charged particles, and their dissociated electrons into the planetary neighbourhood. But Voyager 2 didn't see any of this material. The spacecraft did see intense electron radiation belts, second only to the mighty Jupiter's. But how these belts came to be and persist without a source of plasma has likewise mystified astronomers. A blast of solar wind solves both these puzzles. Like a gust of wind on Earth causing a flag to billow and snap, the solar wind can compress and squash down on a planet's magnetosphere. In the case of Uranus, we calculated that the increase in pressure before the Voyager 2 flyby could have caused a 5-fold reduction in the volume of the day-side magnetosphere. The squashing effect can in turn drive electrons into the radiation belts and push plasma out of the system. Astronomers have observed exactly this effect at both Earth and Saturn, lending credibility to their theory. There's a little graphic here, which I'll just bring up. There's the graphic of this illustration. And I'll just fade my picture out of view there because it's blocking half the picture. There it is. I can just do that, can't I? No, the wrong one. There it is. Okay, so what we're looking at here in these drawings, this is the artist's concept shows Uranus's magnetosphere appeared prior to Voyager 2 arrival in early 1986 at left, and at right is the unusual situation that led to the odd behaviour of the spacecraft recorded when it arrived. Right, so you have to study that drawing there a little, I think. So the article continues on to say that it needs more data. The authors warn, however, that while their new framing of Uranus being in an unusual state during Voyager 2's flyby makes sense, it remains that the spacecraft has provided the only up-close data we've ever achieved from the ice planet, or ice giant. A dedicated mission to Uranus with an orbiter and probe is in the planning stages and would investigate the planet and its moons for 4.5 years. Such a mission was deemed highest priority by the most recent US National Acamedes Planetary Decadal Survey, which guides funding and strategy for NASA's and National Science Foundation, among others. But given the timing of the planet's orbit and seasons, it needs to launch within the next decade, and time and budgets are already closing in on such a plan. Astronomers are discovering thousands of worlds beyond our solar system, but there are still mysteries nearby. Uranus, studied only briefly and from afar, may yet hold surprises for us. So, Uranus, that's one planet that I'm looking forward to trying to photograph when I get my telescopes set up, because I won't be able to get anything like that in my telescope, but you will be able to be, from what I've seen of other people's attempts to photograph Uranus or Uranus, it's the colour that stands out. When you know that your telescope's pointing at that planet, it's the colour that gives it away. So you'll know that you're looking at it. But for those watching the video, you won't see it like that, of course. All right, next article. VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. And courtesy of space.com. Let me see, where am I here? First of all, bring up my camera again. And I'll just get this image ready to show. In fact, I'll bring it up now. And just bring my vision back in again. Okay. This is a James Webb Space Telescope image. James Webb Space Telescope unveils surprising red monsters in the early universe. That's what they say, published 15 hours ago. Our research is transforming our understanding of early galaxy formation. And what you see on the screen right now are these three red monsters that they're referring to, captured by the James Webb Space Telescope, are extremely massive, dusty galaxies that formed in the first billion years after the Big Bang. That's what you're looking at. For a long time, astronomers believed... sounds like the beginning of a science fiction film. For a long time, astronomers believed galaxy formation followed a very specific model. Cosmic gas collects in clumps, stars are born from those clumps, and over billions of years, stellar neighbourhoods gradually increase in size. However, the James Webb Space Telescope, launched December 2021, has disrupted that model. In a new study, scientists identified three massive galaxies dubbed the Red Monsters on the screen right now. Each almost the size of our Milky Way, already in existence just 1 billion years after the Big Bang. Though that sounds like a really long time in our 14 billion year old universe, just a billion years is relatively early on. These galaxies therefore raise a fundamental question: how did they grow so large so quickly? When astronomers initially examined the early universe using the James Webb Space Telescope, they expected to find galaxies in the early universe that weren't fully deployed, but were surprised to discover not only fully fledged ones, but also massive ones. This crisis in cosmology suggested a need to reevaluate our understanding of the universe evolution since the Big Bang. However, there is a wrench in the tail, as in like a spanner. In August, scientists found that these galaxies may appear larger and brighter due to having actively feeding black holes, leading to the conclusion that the unexpected massive galaxies are actually less massive than previously believed. Yet, interestingly, this new study revealed no evidence of what are known as active galactic nuclei, or AGNs, in these galaxies, ruling out the possibility that their intense emissions come from supermassive black holes at their centres. Therefore, the crew concluded that the extreme characteristics of these galaxies, high mass and rapid star formation, are inherent to the galaxies themselves and not driven by any active nucleus. How could this be? The study was led by an international team of University at Geneva and utilised data from the FRESCO survey, F-R-E-S-C-O, the FRESCO survey of the James Webb Space Telescope. It focused on galaxies with redshift values between Z5 and Z9, when the universe was only 1 billion to 1.5 billion years old. Redshift measures how much wavelengths of light coming from distant objects stretch on their way to our detectors due to the expanding universe, with higher values indicating greater distance and age. The team used the FRESCO near-infrared camera, a GRISM spectrograph, to measure the galaxy's distance and stellar masses. The instrument on board the Space Telescope allows us to identify and study the growth of galaxies over time, and to obtain a clear picture of how stellar mass accumulates over a course of cosmic history. The team's analysis centered on 36 massive, dusty, star-forming galaxies, selected for their unique red color and predominant emission lines, indicating they are massive and significantly obscured by dust. While most galaxies matched theoretical models of galaxy formation, 3 were categorized as ultra-massive and had unusually high star formation rates. The 3 red monsters appear red in the James Webb Space Telescope's images due to their large dust content, which makes them absorb shorter wavelengths of light and scatter the remaining light into longer reddish wavelengths. The James Webb Space Telescope can observe them so clearly because it captures infrared light, enabling scientists to see past the dust, unlike the Hubble Space Telescope, which is limited to optical light. This ability to see through cosmic dust is one of the reasons James Webb Space Telescope was revolutionized, or has revolutionized, our view of the universe. Returning to those red monsters, the new James Webb Space Telescope data showed that these galaxies produce stars at about 2 to 3 times more efficiently than galaxies in the later universe. The stellar masses of these 3 galaxies are so large that they require a stellar mass conversion efficiency of about 50% higher than the typical efficiency observed in galaxies today. For example, most galaxies at later times convert only about 20% of their available gas into stars. These findings suggest that the early universe may have had a different set of conditions that allowed for much faster and more efficient galaxy growth. I'll just leave that there at this stage. So that article is courtesy of space.com, and it's published 15 hours ago, titled James Webb Space Telescope Unveils Surprising Red Monsters in the Early Universe. You're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Just stand by a tick while I turn that down. Just turning down one of the wirelesses there in the shack. Alright, now let me bring up the next image on the scheme of things here. This is a meteor image. Okay. Now I've only read this article very quickly. Courtesy of sciencealert.com. This meteorite that you see on your screens right now just revealed an ancient signal of water on Mars. And I won't read all this article out, just enough to whet your appetite. This was published 22nd of November. And of course the image you're seeing on the screen right now is it says here that it's most of the Lafayette meteorite is kept at the Smithsonian National Museum of Natural History. So that's what you're seeing on the screen. Anyway, evidence is growing that Mars was once sloshy and wet, draped with lakes and oceans, which lapped at shorelines and deposited sediments that are, even as you read these words, being scrutinized by robots rolling across our now dry and dusty surface. Water was there. We know it was. But piecing together when and how and where it went is a little trickier to figure out. But we just got a big clue. A meteorite that was ejected from Mars 11 million years ago and subsequently made its way to Earth reveals that there was liquid water on Mars less than 1 billion years ago. According to a new analysis of the Lafayette meteorite, minerals within it formed in the presence of water 742 million years ago. It's a real breakthrough in the dating of aqueous minerals on Mars, and suggests that sometimes Mars might still be a little damp. Dating these minerals can therefore tell us when there was liquid water at or near the surface of Mars in the planet's geologic past. We dated these minerals in the Martian meteorite Lafayette and found that they formed 742 million years ago. We do not think there was an abundant liquid water on the surface of Mars at this time. Instead, we think the water came from the melting of nearby subsurface ice called permafrost, and that the permafrost melting was caused by a magmatic activity that still occurs periodically on Mars to the present day. And there's another image here which I've got. Bring that up. Okay. And what you're seeing on the screen now is a piece of the Lafayette meteorite. I don't know why it's called Lafayette. They haven't quite come across that yet. One of the materials in question is a type of rock called Iddingsite. 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 Iddingsite, maybe, which forms from volcanic bauxite in the presence of liquid water. The Lafayette meteorite contains Iddingsite, which itself fortuitously contains inclusions of argon. Dating minerals can be a little tricky, but we've been getting much better at it as our technology advances. A technique called radiometric dating can be used on isotopes of argon to obtain a precise record of when the element formed. Argon emerges from the radioactive decay of potassium, but when there is no potassium present, a single sample of the isotope argon-40 can still be dated. This is because the amount of lighter isotope argon-39 that emerges when argon-40 is irradiated in a nuclear reactor is dependent on the amount of potassium that was present initially. This means the argon-39 produced can be used as a proxy for potassium, and since potassium decays at a known rate, this means that scientists can work out how long it has been since the rock formed. The researchers used this technique on a small sample of the Lafayette meteorite to work out how long it had been since water and rock had interacted to create Iddingsite. Being ejected from Mars during an impact event, zooming through the solar system and then falling smack into Earth through its atmosphere, being heated on the way down, can also change rocks. The researchers were able to model and account for the temperature changes experienced by the meteorite on its long journey, and to determine what effect, if any, there would have been or would have had on the apparent age of the sample. The estimated age could have been affected by the impact that ejected the Lafayette meteorite from Mars. The heating Lafayette experienced during the 11 million years it was floating out in space, or the heating Lafayette experienced when it fell to Earth and burned up a little bit in Earth's atmosphere. But we were able to demonstrate that none of these things affected the age of the aqueous alteration in Lafayette. The findings place new constraints on the known data, or the known date of moisture on Mars. The new date, the team also found, coincides with a period of heightened volcanic activity on Mars. Such activity seems much quieter now, But recent observations by the Mars InSight lander have revealed that there's a lot more going on inside the planet than its innocent exterior suggests. But the results don't just have implications for our understanding of Mars. The team's techniques have broader potential for understanding the solar systems, including the open, burning question of how Earth got its water billions of years ago. We have demonstrated a robust way to date alteration minerals in meteorites that can be applied to other meteorites and planetary bodies to understand when liquid water might have been present. Right, so that article was courtesy of Science Alert, published 22nd November. This meteorite just revealed an ancient signal of water on Mars. Yes, that's quite an interesting looking object. You're tuned to ASV Radio, VK3EKH, where no wrinklies fly. Next article. Okay. 16 minutes to 11. Courtesy of Science Alert again, published also 22nd of November. Scientists reveal humanity's first close-up of a star beyond our galaxy. And I'll go straight to the image. That one there. Okay. A star more than 160,000 light years from Earth has just become the epic subject of the first close-up portrait of a star in another galaxy. It's called WOHG 64. WOHG 64. A red supergiant star in the Large Magellanic Cloud dwarf galaxy orbiting the Milky Way. It's so large that it has, for some years, been known as the Monster or the Behemoth, clocking in at nearly 2,000 times the radius of the Sun. The colossal size is what made it such an ideal target for a portrait using the Very Large Telescope Interferometer at the European Southern Observatory. It's big enough that we can zoom in and see details that we've never seen before. We discovered an egg-shaped cocoon closely surrounding the star. We are excited because this may be related to the drastic ejection of material from the dying star before a supernova explosion. Imagining stars right here within the Milky Way is hard enough. Imaging, not imagining. Struth, Clint. Imaging stars right here within the Milky Way is hard enough. The red giant star Betelgeuse is a perfect example. In spite of being 764 times the radius of our Sun and less than 650 light years away, our images of the object are so fuzzy that astronomers are still trying to puzzle out why its light fluctuates so dramatically. WOHG 64 is around 3 times the size of Betelgeuse, but 250 times the distance. So it appears much smaller and dimmer to us than Betelgeuse, which is one of the brightest stars in the Earth's sky. Just reading ahead of it here. The technology takes the form of an instrument named gravity, designed to observe very small, very faint objects. Given how far away WOHG 64 lies, it certainly fits the bill for small and faint. The researchers took their observations in December of 2020 and then had to undergo the painstaking work of cleaning up processing and reconstructing the data to resolve their target. So, while the image may look fuzzy, the level of detail the researchers were able to obtain is nothing short of incredible. Observations taken in 2005 and 2007 revealed that WOHG64 is surrounded by dusty material. Since the star is in its red supergiant phase, this is exciting. It's the end of life for massive stars that started out between about 8 to 35 times the mass of the Sun. As the star runs out of nuclear fuel to fuse in its core, it becomes unstable, burning very hot and puffing up to a large or to a huge size before exploding in a supernova. The dusty material revealed that WOHG64 is at a very unstable point in its life, experiencing violent mass loss as it grows near to the end. Now, the new observations have revealed that the star has actually grown dimmer. We have found that the star has been experiencing a significant change in the last 10 years, providing us with a rare opportunity to witness the star's life in real time. The researchers think that the star's dimming may be a result of the mass loss it's been undergoing. The gas and dust it sneezes out blocks some of its light from reaching us, making the star appear dimmer to our telescopes. It was the ovid egg-like shape of ejectica bubble that the scientists found surprising. Their modelling based on previous observations suggested that the shape should be different. It's unclear why it has the shape it does, but there could be several explanations. It could be something to do with the way the material is ejected, the way it moves through space around the star, or even the presence of an as yet unseen binary companion sculpturing the outflows in some way scientists have yet to determine. The behemoth represents fairly uncharted and exciting territory. The mass loss stage of the red supergiant lasts a few thousand years, which means that the star is really right on the brink. It could tell us things about the way massive stars end their lives we've never seen before, says the author. So, that's an interesting object to look out for. WOHG64 in the in the galaxy of the Large Magellanic Cloud. So that's an interesting one for astronomers to look onto. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, where the time is now 11 minutes to, and let me just pick and choose my articles now as we get down to the hour. All right, this is something to do with Boeing. I better check where my camera is. Okay, we can go off that now. So I'll just fade me out of view there and bring in me there. And now, this article has just one picture in it. Nothing much really to write home about, but there was a picture, so I shall bring that in. If I did bring it across, there it is. All right. So what we're looking at there, Boeing's Starliner spacecraft as it approaches the International Space Station on June 6. That's how it looked. How big is this article? This might just take up the rest of the 10 minutes. The past, present and future of Boeing in space. Although the future of the legendary aviation company's space sector is up in the air, its legacy has long shaped travel beyond Earth. In October, the Wall Street Journal reported that Boeing may shed its space business to focus on commercial aircraft and defence systems. This could be due in part to this summer's test flight of its Starliner crew transport to the International Space Station, which adversely reshaped public opinion on the beguiled aerospace titan. But despite some of its bad publicity, Boeing, 6 decades in space, have helped to facilitate a permanent off-planet US presence and enabled our first footsteps on the moon. Even before Starliner's first flight brought Boeing poor press this year, the capsule's evolution proved troubled. In 2014, the company won a $4.2 billion NASA contract to build the International Space Station crew capsule. A botched test flight, Scan's crew, in 2019 failed to reach the space station, and despite success in 2022, problems continued to mount. This included propulsion system faults, flammability issues, and adhesive tape, and worries about parachute safety. Adhesive tape? It piled unwanted pressure on Boeing, which was already weathering negative publicity after fatal crashes of its 737 MAX aircraft in 2018 and 19. A door plug blowed out on another MAX in 2024 forced an emergency landing, and a 7-week mechanics strike ended this month after grinding Boeing's 737, 777 and 767 jet production to a standstill. Against this gloomy backdrop, Starliner launched its first astronauts, NASA's Barry Butch Wilmore and Sonny Williams, in June for a planned 8-day ISS stay, but helium leaks and rejection control system failures repeatedly lengthened their mission. Days turned into weeks and weeks became months. NASA opted to return Starliner to Earth empty in September and keep Wilmore and Williams in orbit until February. Boeing is tasked to fly 6 more Starliner crew rotation flights before the International retires and is deorbited after 2030. But as engineers dig into what went wrong and delays continue to mount, the problem's future is left hanging precariously in the balance. It is a huge blow to the company whose name is synonymous with aviation and whose machines for decades have piled the world's skies and other skies beyond. Just seeing the rest of this article. In brief, in 1961, NASA picked Boeing to build the SIC first stage of the Saturn V. This behemoth was, until 2020, the biggest and the most powerful rocket ever brought to operational status. Flown 13 times between 1967 and 1973, it sent 24 men to the moon and put the largest single object into Earth orbit, America's first space station, Skylab. Standing at 138 feet, or 42 meters tall, the SIC held 193,000 gallons of kerosene and 265,000 gallons of liquid oxygen. Its 5 F1 engines produced 7.7 million pounds of thrust. The SIC burned for the first 168 seconds of each launch, lifting the behemoth to an altitude of 72 kilometers at a velocity of 8,200 kilometers per hour before the Saturn V's upper stage took over. For the astronauts, riding the SIC was an unearthly experience. Like distant thunder of a storm far over the horizon, wrote Apollo 8's Frank Borman. A guttural roar you felt, rather than heard, said Apollo 10's Tom Stafford, while Fred Hayes of Apollo 13 recalled the pronounced herky-jerky left-to-right motion introduced by the F1 engines. But Boeing's involvement with the Apollo ran deeper. It built 5 unmanned lunar orbiters, which from 1966 to 1968 mapped 99% of the Moon at resolutions finer than 200 feet, or 60 meters, critically aiding NASA's selection of Apollo landing sites. The company also built the 4-wheeled lunar rover, called the Lunar Roving Vehicle, or LRV, which was used during the last 3 Apollo missions between 1971 and 1972. Described by Apollo 15 astronauts Dave Scott as a brilliant piece of engineering, the battery-powered rover achieved a top speed of 10 miles an hour, 16 kilometers an hour, on the Hamoki lunar surface, covering a maximum distance of 22 miles, or 35 kilometers, and reaching almost 8 kilometers from the lunar module. 3 decades later, as NASA again zeroed in on the Moon, Boeing was tapped to make the second stage of the Ares 1 crew launch vehicle, a rocket later cancelled in 2010. But in 2011, the Space Launch System SLS rocket was born, with Boeing chosen to build its 212-foot tall, 65-meter core stage. Fed by 4 Shuttle Heritage RS-25 engines, it generated almost a quarter of the 8.8 million pounds of thrust needed to lift the SLS off the ground, the rest coming from 2 solid fuel boosters. Just reading what's left here. Yeah, it's just a little bit more to read here, but I think what I might do, I'll probably, I might revisit that towards the end, towards next week, as a part 2. I'll make it a part 2 of the Boeing story, the past, present, and future of Boeing in space. Yep. All right. I just don't want to go on anymore at this stage. All right. And I shall now skip straight to spaceweather.com. Let me just bring up our sun. And the solar wind is currently at 410.3 kilometers a second at a density of 3.76 protons per cubic centimeter. The current disk of the sun facing the Earth right now has more than several sunspots on its surface, which you can see on the screen right now. Quite a few. The current sunspot number is 148, whereas the radio sun at a wavelength of 10.7 centimeters is 163 solar flux units. The KP index is 0.67. The 24-hour max KP figure is 3, both considered quiet. There is no significant equatorial coronal holes on the Earth side of the sun at the moment. And there's a solar radiation storm in progress. Now I do have some video of this, so let me just switch that up. There it is. I'll put that on a loop. They're saying here that solar radiation storm in progress today. Earth and all of our planet's satellites are being hit by a blizzard of energetic protons. It's an S2 class solar radiation storm. You can see the particles in this coronagraph movie from the Solar and Heliospheric Observatory, SOHO. Each snow speck in the movie is caused by a proton hitting the spacecraft's camera. Fogged cameras are a problem for satellites like SAHO during storms of this size. The source of the storm is also shown in the movie. It's the CME emerging from the far side of the sun at the 2 o'clock position. Shock waves in the leading edge of the CME are spraying energetic protons throughout the solar system. Here on Earth, we are safe. The protons are not able to reach the ground. So just don't try to use a shortwave radio in Antarctica. A deep radio blackout is underway over the frozen continent. And there is an image of this, actually. Where do we go for that? That's this one here. So all that area that's in red is a radio blackout. No HF comms are possible within that area. The red zones in this blackout map show where signals are strongly fading because of the ionization in the upper atmosphere. Why Antarctica? At this time of the year, the South Pole is tipped toward the sun, the source of the protons. Okay. All right, and there's not, as far as the auroral activity is concerned, there's not much to write home as well. It's very, very small ring of activity there. You can see there's a little bit of green over Antarctica, but there's not a whole lot of auroral activity happening as we speak. So there's that, and I don't think there's much else to report from there. As of the 21st of November, this has changed. What's changed? No, I'm looking at fireballs. Okay. As of the 22nd of November 2024, there were 2,349 potentially hazardous asteroids, but none of those asteroids are on a collision course with Earth. Okay, that's the solar report over and done with. So on that note, we shall conclude the session for tonight. What else can I say here right now? No, I won't worry about that. Okay, I'll leave that alone for the moment. Okay, so on that note, we shall conclude. We shall go across to the frequency 3541 kilohertz and pick up any stations that wish to check in. Let me just get my audio here set up so this can be patched through to Discord and YouTube. I think that's good enough there. Let me go back to vMix. Alright, this is VK3EKH listening on 3541 kilohertz for any stations wishing to check in.
VK3JR, VK3JR, VK3SPX.
All right. VK3GOD, VK3JR. I wrote these very quickly. VK3SPX, VK5 Whiskey Alpha. Is there any other stations I missed out?
Yeah, you missed me the front, but VK3 Tango Julius Sierra. G'day.
G'day, Jack. Yeah, I thought you were there. All right. Any other stations? Okay.